Hello and welcome to the how-to video for building the Open Autoclave. It's an open source off-grid medical instrument sterilizer, and let me show you what it is we're going to be making. The Open Autoclave is essentially a small oven that you can build. It's computer controlled, so it will run a special cycle of temperature over time to kill bacteria from medical instruments. It's also designed to run off-grid, meaning it can be powered by 12 volts, either from an automobile, or it can be run from a small solar power system. The controller is all open source hardware. It's got an Arduino microcontroller and just some automotive relay parts and generally things that are available from a lot of different sources, so you're not locked into any particular vendor. If you look inside the body of this little oven, the part that holds the heat is a stock pot. It's a stainless steel pot wrapped in ceramic fiber insulation, and that's been wrapped in aluminum foil and in aluminum furnace tape, something that's actually very durable despite looking like a baked potato. Inside is a set of little pizza racks, and the top rack is about 10 inches wide, big enough to fit wrapped medical instruments. On the top, wrapped in linen, and then inside is a set of heating elements, 12-volt heating elements, the kind that you would find in a 3D printer, so something very available, very low cost. Elements all run back to the controller, and the whole thing is set up on a neat little cookie sheet, which is something that's available. They're very durable and also very strong. So let's go ahead and show you the book for a second. We're going to be referring to this book, which is available online as a free download. You can download it from a number of sources for free. I'd recommend that you print it when you go to build this so that you have something to refer to, or you can order a copy of the book already printed, and I'll include a link for that too. So why don't we go ahead and get started. We're going to build ourselves an open autoclave. Chapter 1 is setup, and basically we're going to just look at the tools and all the parts that you need. So we'll run through this really fast. We need to get a cordless screwdriver. We're going to drill some holes. We're going to screw in some screws. You need to find a set of drill bits. I've got also a sharp punch for marking position of holes. I've got a Sharpie here. Needle nose pliers. I have a little hacksaw. You can also use a cutting wheel or cutting disc. Makes life easier. We've got some regular pliers. I have a ruler. Ruler has inches and millimeters that comes in handy when you're checking some printouts. Tape measure for measuring insulation. We've got a little utility knife for cutting insulation. A pair of scissors just for cutting paper, making a little template for marking holes. Set of screwdrivers, nothing too complicated. I have small and large of the Phillips, small and large of regular or flathead. Here is just a set of Allen wrenches or hex keys, whatever you want to call them. This is metric. For some reason, the parts that we order that use these, they're all metric, so go ahead and get a set of metric. When we get into checking the wiring, having a volt ohm meter is essential. It'll let you know if wires are connected properly. Finishing up the wiring, I've got wire cutters, some wire strippers. Here's a handy thing to have too. This is it has a cutter right here. It has wire strippers, and then it also has this up here for crimping connectors on. And one part we're going to crimp some connectors on, so you might want to consider just finding this. Optionally, here's a soldering iron and some solder. I've tried to set up the instructions so that you don't have to solder anything necessarily, but it always comes in handy to be able to do this. Likewise, it's optional if you want to get a set of crimp connectors and a crimper. Maybe you've never seen these, but it's pretty cool. You can make tiny little connectors that will plug into the circuit board on the Arduino microcontroller, and you use this to crimp these little metal pins on to a set of small wires, so optional, but that is a run-through of all the tools that you'll need. Likewise, there's a list in the book of all of the different parts that you'll need to construct the open autoclave, and I have them all laid out right here, so I can go ahead and just show you. The main parts of the autoclave are made from a stock pot, which is a stainless pot. We're going to cut the handles off. Here is a set of ceramic fiber insulation sheets, something you can order. It's a little bit messy, it's wrapped up there. We've got this aluminum furnace tape. This is great stuff. It's very sticky. It's also very strong. Does a great job of holding things together in a way that is airtight. Here's some aluminum foil. This is the heavier kind of foil. It's also known as food service foil, and it's a little bit thicker than the kind you might just buy at the normal grocery store. Underneath all of this is an aluminum cookie sheet. It's the 13 by 18 inch size, so it's kind of you'd call this a half sheet. These are 10-inch pizza screens. Actually, I think these are 8-inch pizza screens. It's in the book. You'll see it. I have a bag of screws, and we'll look at those as we use them. This is a little black iron pipe surface mount, and it's used in the heating element. We'll use it for our heating element. Likewise, there are these small aluminum blocks. They're heater blocks for a 3D printer, and you use those along with these. These are the heating elements that you can buy for a 3D printer. Basically, they are assembled by putting them in there, and then they can be bolted down. It lets the heat conduct out of these very readily instead of overheating the elements. Let's see, I've got some little rubber feet for the bottom of this whole deal. I have some of these little wire nuts. And getting up here, we're getting into the electrical supplies. This is a little electrical enclosure. You can order these online. Again, in the book it says the different sizes, the most likely sizes you'll find. Here is a hookup. It's a 12-volt hookup for an automobile, so it's a utility plug hookup. I have a little USB printer cable that's useful when we get to the point of programming the Arduino. Having a couple of these little connectors, these already have little pin connectors on them. This lets you get away with not having to solder anything. So if you look at this, they have female plugs at one side and male plugs on the other side. And you can order a set of these on Amazon or wherever, and you can get a set of longer and a set of shorter. And it lets you piece everything together really without having to solder anything. So very handy. There are some bigger pin connectors. I'll grab a couple of these. These are great, and we need these for hooking up the higher power wires that the heating elements use. Right down to here, we've got the Arduino Uno microcontroller. If you've never played with these, don't worry. They're actually remarkably easy to set up and program. It's a small computer. You can program it, and then these pins connect to different things. If you order it from Arduino, it also comes with this little sled that it mounts on, a little bracket for it. Very handy. This is a small liquid crystal display screen, and the kind that we have has what's called an I2C port. So this whole screen can be operated with just 4 wires. So the thing to look for when you're ordering it is I2C or I2C. It has 4 wires that let you do everything with the screen. There's usually a little separate circuit board on the back. If you don't have I2C, then this screen actually needs about 16 wires, and we don't have enough ports in the Arduino, so I2C is key. Here's a 12-volt automotive relay, the kind of thing you can buy from any kind of auto supply store. It has a little schematic on it. It'll show us how to hook this up. Here's just a switch. This is handy. I just found an on-off toggle switch. Moving right along. This is the temperature reading system, temperature reading equipment. This little chip is a thermocouple reader, and it's the Max 6675. That's the kind that I used because it's the most inexpensive and the most available right now. You may choose to use a different kind, but you might find that you have to use a different library with your code, so we'll get into that later. It also comes with a small thermocouple. So this is the temperature sensor, and then these are the wires that would connect positive and negative to this system when you open it up. Moving right along, this is a tiny it's a tiny transistor switch. So this lets the Arduino controller control bigger loads or bigger currents. You put power from the Arduino in, and it's called a MOSFET module, and you'll see that in the instructions too, a MOSFET transistor. We've got a tiny little speaker. This will let our autoclave make alert sounds, and I've programmed it to make a couple of cute little sounds when it starts up and make a sound when it's done. Also make a sound if there's a problem. It's having trouble reading, it'll make some unhappy noises. We've got a little tiny push button. Pretty simple. This will let you start the cycle or restart the timer. And lastly, just some electrical tape. So that is the set of all the supplies you need for this project. Why don't we go ahead and jump right in? Well, the first real step of this process is to cut the handles off so they're not in the way when we go to insulate the pot. We don't need the lid at all. I'm just going to set that aside. And I know I said use a hacksaw, but I'm going to go ahead and use something to make life a little bit easier. It's a little friction cutter. A note to anyone using power tools, make sure you wear eye protection and maybe ear protection, because this could really hurt you. We're going to go ahead and buzz this right off of there. And that's it. We'll go ahead. That's it. We'll just do the other side too. The next part of this whole process is just putting insulation on the pot. The first thing we're going to do though is we're going to wrap the pot with an inside layer of foil, then the insulation goes over it, and then we'll put more foil over the outside. The easiest way to do this, and it's a little bit finicky, is you would wrap some foil entirely around the pot. Notice it's actually loose, so leave a little bit of room there. That's pretty good. And we're going to make a little lip all along the bottom. So see that, how there's kind of a lip in it? Just very, very loose. We're going to wrap it all the way around now. And you can do what I like to call just sort of a folding weld. So you would just twist that together a little bit, just to kind of weld it together, weld it to itself. Same with this edge here. A little bit of a mess right now. Just kind of put that right over. I'm gonna also, here's the pocket. I'm gonna also come down here and just twist this little pocket together. Again, this is just, it's very, very loose. This is kind of a preliminary step to the whole thing, but that's basically what we want. It's just gonna form sort of an inside layer of foil, It'll help contain the insulation and also reflect some infrared, gives another layer of reflection to make the heat retention a little bit better. The next step is to use the ceramic fiber insulation to make the wrap around that pot. Notice I have some gloves on. It's nice because this stuff, although it's non-toxic, it tends to make a lot of powder and sheddings, and it is slightly fibrous. It's also not very good stuff to breathe, so feel free to wear a mask or just some kind of dust mask. Do this in a well-ventilated area, and preferably do it in an area that's easy to clean when done with. I can just sweep or vacuum the rest of this up. So I'm going to go ahead and pull this stuff out. I know what the measurements are for this insulation, so I'm going to bring this out and I can measure out the lengths that I need. The first section that I need is going to be 30 inches long and 9.5 inches wide. So looks like, measuring this stuff out, it's about 24 inches long there. So another 10 inches would make it 30 inches. It's right here. I have this metal ruler, and it's actually very easy to mark. You can kind of lay a ruler in and make a little mark like that, and it shows up. Go ahead and measure. I did a pretty good job. 30 inches. Good. I might mark it a little bit more. So we're going to cut along this. I'll use our utility knife. Again, it's a very friendly material to work with. It just tends to make some shedding, so be careful when you're doing it. We're going to make it 9 inches wide. Make a little mark right here. And make that right up to here. Sometimes it's easy to just make a few marks along it so you can kind of see where it's going to be, and then again use the metal ruler to scoot it down in there. Leaves a nice little dent. It's easy to cut across. There. So I'm just going to measure again and make sure that I'm close, but 9 inches, 9 inches, 9 inches, and then the total should be 30 inches, so that's good. Good. Notice this is actually in separate pieces. That's okay. We can piece this stuff together. It holds together really nicely. So I'm going to go ahead and slice through in a couple of passes. Also, something I like to do, I like to save all of these little scraps because it's handy. It's really neat material, incredibly high R value. You can use it to build a kiln if you wanted to. Okay, there we go. All right, so we have that. Let's go ahead and put it into the edge of this pot. This over here. See, there's a spot where we seamed it together. It's a good idea not to have the seams of this stuff all line up. So I'm going to put the broadest part of this right in here. Give me a second to get myself lined up. Just going to kind of tuck it right into the edge. All right, so I have this insulation set in to that lip around the bottom, and can see it when I pinch this together, it seams together and it just comes right up so it's flush to the top. I'm going to go ahead and use this foil tape to kind of restrict around it, and that'll let me pull it tight and just get it all fitted on properly. I like to peel the tape as I go, because if you peel it all at once, the tape just sticks to itself. So just peel it as I go, turn it right around, keep it moving, and adjust this as I go. Okay. Now the fun part, I'm gonna just try to bring this seam together, close that seam up a little bit. Okay, I just wanted to show this to you. This is sort of a preliminary stage once again, but see, I've got tape wrapped around, it's holding the seams together. Now we're going to go ahead and make the top for this, and the easiest way to do this is to just have a piece of ceramic fiber insulation out, take the whole deal and just line it up on there. That's easy. And then go ahead and you can use this ruler, or you can just use the cutter and mark right around it. Just gonna mark right around. Makes it easy to ensure a fit. Right around there. Okay. Yeah, pretty good. I can see the outline. So I'm going to go ahead and just cut this all out, and we'll put it onto the underside of this. Okay, so I've got that cut out. We're going to go ahead and just put that right on top there, and you see it actually can line up around there pretty nicely. And if it's pushed down, there really isn't any seam. That's what we want. So I'm going to just put a couple of strips right over the top just to hold it temporarily while we get things ready to put foil over the whole outside. See if I can do this with tape fingers. Here. So that just holds it so there's no open seam. And again, I'll just kind of put down there. There. Push it down there. Just push that right there. All right. That forms the body of the oven. Now what we're going to do is just wrap the entire outside with a couple layers of foil, and then we're going to secure the rest of it with this tape. So I've gone all the way around twice. I'm going to go ahead and just tear this off as evenly as I can there. Okay, and it goes just clear down to the bottom. I'm going to just kind of start with the top here and fold it around a little bit. And then we can just fold it right in, like we're maybe gift wrapping a present. Just make a nice closed container. Like that. And now the last thing to do is just secure everything using the aluminum tape. Something that I really wanted to show you is how that outer wrap of foil comes right down, and this is that under wrap. So it kind of wraps right under, and there's no gap along the bottom. What we don't want to do with the tape is you don't want to ever have any tape wrap inside the autoclave, because the adhesive of this tape actually will burn and the smoke will contaminate the contents. So all of the tape needs to be kept outside the autoclave. That's why we're wrapping it right down to the edge but not inside, and we're not actually sticking any tape to the pot that's inside. Just going to put one piece of tape all the way around the outside here. Try not to make a huge mess, but get it right around there. There. And now we'll just fold it right down. Alright, I'm just wrapping a little bit more right over the top. Kind of smooth it down by hand. There. So that's what we're after. It's a completely wrapped pot. It's stainless inside, no tape around the edge, but the foil 100% contains that insulation. And that's the oven section. We're going to make the base section now, and we're just going to cut a square of remaining, these are some scraps of this insulation. Now if you look at this, I'm just going to use this ruler, it should measure off to be right around 12 inches inside, and that's the width that this is already cut to. So I'm going to go ahead and just measure out to be right around 12 inches. You can mark it at 12. Again, I can use this ruler. It's okay, it's not exactly perfect, but it's big enough that it will provide a good base for that to sit on. Again, I'm just going to cut this to be a nice little square section. And if you want, we can just try it just to see how the fit is. So that will go there, and then this will sit neatly right on top of it, and it's enclosed all the way around. If you press it in, lift it up, there. You can see the lip of the stock pot inside is in contact all the way around, so this is plenty big. We're going to just enclose this in foil now too, and it's actually a lot easier than what we did. I can just lay out a piece of foil like that. We'll go ahead and put this right on there. We can wrap this over. We're just going to make a big pillow. Wrap it over a couple of times. The whole point of doing this is to just enclose that insulation so it doesn't ever come out. It's non-toxic, but it is kind of messy. And the powder can be a little bit of an irritant sometimes, so I've got that wrapped. I'm going to do another little fold weld like we did around the edge there. Just going to roll it up. And just flip it right around. Do the same thing right here. Okay. That looks good. It feels nice. Now the last step with this is we're going to go ahead and put it onto the tray. And we're going to use some of this tape to secure the edges, secure it right into the edges of the tray so it doesn't come out, it doesn't move around. There's enough room here at the front of the tray for the control panel, which will be bolted into the tray when we get to that point. So we'll go ahead and measure some of this. Notice I'm keeping this pretty close to the edge so that it doesn't end up going underneath where it gets hot. Just having it under the edge here. Having it under the edge will hold it in place. Tape this right along there. While I'm at it, I'm going to go ahead and I'm going to put some little feet on the bottom. These little peel-off rubber feet. It's kind of nice. So if you're using this on a countertop, it won't slip around. There. There. So there's the tray, the insulated pillow, and we'll go ahead and we could put this right on there. And that's the enclosed oven arrangement for the autoclave. Okay, the next thing we're going to do is assemble the heating element using some screws. We've got the iron pipe flange and these little heater cartridges. What I want to do is mount these aluminum holders for the heating elements onto this flange. Now they have little set screws you can screw in to hold the elements in place. Also, these are threaded, so all you really have to do is take a screw. These are M6 screws. Depends on what kind you order, but that's generally what they are. It's a 6mm screw. Get it? Get it on there pretty close. And you can kind of tighten it by hand, backed off a little bit. I want it to be tight with that little heating element hole sticking outward. That way I can aim the elements with the wires going out. Now I could tighten the whole deal a little bit more by just grabbing it, giving it a little turn. There. And that's actually very tight against the bottom of that flange. If you wanted to, you could polish this down. It would give it an even smoother surface and a slightly better thermal contact, but it's not really necessary. So I'm going to go ahead and do the other ones. Should be pretty easy. None of this takes very long to do. Back it up a little bit. Get that so it's finger tight. I'm going to back it up a little bit more. All right. And you know, that's also what having this tool is for. I could quit trying to cheat and just go ahead and put that right in there. Kind of get this positioned how I want it to be. Give it a little bit of a turn. I'll lock it right into place. And then if I wanted to maneuver it a little bit, boy, that's really tight. That's what I want. There. Notice I'm leaving it so these little set screws are available when I go to put the elements in. Get that right where I want it. Once again, the elements are pointed out. You'll see when I go to install the elements why they're facing out that way. There. That's nice and tight. Those are all very secure. And now, switch the tool to the size that would fit into these little tiny screws. There's one smaller size than that. There. Gosh, it's got to be like a 1.5 millimeter. It's gonna be really tiny. But there. So I can loosen that up, and then I'll just start putting the heater cartridges right in. They slide right in, flush with the end like that. Give it a little push there. You don't want to be too tight, just enough that it's really in there. Don't crank on it because you can actually damage the heater cartridge. So I'll put this in there to loosen that up. Once it's loose, you can push it right in. A little bit looser. Yeah, it's right in there. Having the cartridges go into these blocks lets the heat from the cartridge go out into this larger iron piece, and that has a higher surface area, and it will let convection happen to carry the heat away from the element. If you just put raw elements into an oven, at least elements like this, they'll burn out pretty fast. So doing it this way extends the life of these otherwise very inexpensive elements. It lets you get away with doing a lot more with less. Okay. There. Now notice I've left all of these wires long. We'll trim those wires down later, but for now that's what we're after for this step. There are some nuts that fit on these, and I can put those on temporarily so I don't lose them. There. Okay. All right, the next step is preparing these pizza screens for use as the two trays. When it's finished, they're going to be sitting like this, one above the other, and they're supported by legs that'll be made out of these carriage bolts. And the bolts, actually I have one that's put together. The bolts will have the foot, so the rounded end will become the foot. There's a nut and a couple of washers that sandwich one pizza screen, another nut. There's a space, and then a nut, a couple of washers, and another nut, and the top screen will be sandwiched there. The tricky thing, or I'd say the key thing, is to just get the holes lined up. It's not super critical. I'm going to kind of line this up so it's the holes in the screen line up. What I want to do, and this is not very high tech, is I'm going to use a screwdriver to poke the holes through both screens so that the screws can go right through. What you want to do though is put a mark like that so that you know you're using the same holes. That way you don't even really have to measure. You don't have to be super precise. So I'm going to go ahead and just pick a spot somewhere near the edge. Again, not super duper high tech, but this is a very effective way of doing this without too much trouble. And if you want, you may choose to stick a bolt through that holds the alignment while you're doing the next one. There. Okay. And we'll do the next one. Notice I'm really just doing this by eye. It will work just fine. It just has to stand up inside the autoclave. There. And then this foot will go through. So I'm going to go ahead and pull these out. Okay, so I've got these bolts out. Before I assemble them with the legs, what I want to do is choose one to be the bottom. I'm going to say this one's the bottom. And we're going to go ahead and put the heating element onto that, just like this. So I've got this element that we just did. I'm going to try to wrangle the wires a little bit. I can take off the nuts that I put on there. And here's the thing, we can just set this down, and I'm going to flip this over, and we're just going to see if we can wrangle that so it goes right in, pops right on there without too much trouble. And if you need to, you can open these up a little bit, once again using a screwdriver. May or may not need to do that. This whole project is really meant to be something you can do with hand tools and not kind of a whole shop worth of stuff. And the reason I'm doing this kind of fast and dirty is to just illustrate that it can be done by almost anyone without a whole lot of skill behind it. I mean, I'm really just poking screwdrivers through this little pizza screen. If you have the right parts and some basic hand tools, you can assemble a working medical instrument sterilizer. Alright, so the next thing is I put these washers on, and I've got this Allen wrench right there so I can hold this securely. Oops. Put the washer back on there. And the 6mm, or the M6 nuts will just go right onto those bolts. I'm going to just put them on finger tight first and then tighten them up with the wrench. Okay, then I can tighten them up using a wrench. We're using these pliers. Alright, now that I've got these nuts on there, this is bolted in place onto the pizza screen, the last step with this layer is to run the wires. See the wires of the heating element? They run right out through the mesh. So I'm going to do the last one. It's right here. These wires will trim to length when it's time, but I'm just going to put this here. I don't want it to cover that small hole. That's where the feet are going to go through, so I'll just run it sideways from that a little bit. And just kind of pull those through. Be gentle. You don't want to cut the wires or the insulation against the screen, but doing it this way acts as a little bit of a strain relief. If these get tugged, they're not pulling on the heating element, so that helps. All right, so this is the bottommost layer of the inside heating element section, and now we have the top layer, which will go right above it. Okay, we're going to start by putting the feet into the bottom of the 2 pizza screens. I have the 4 feet set up with a nut and a washer, and it's set up so that, I'll hold a ruler up, it's set up so that the bottom of the, so at 1.5 inches the nut starts. So right here is 1.5 inches. It's 1.5 inches from the bottom of this to the top of that nut. And here we go. We're going to just take this screen and we'll locate those holes that we'd made before. Put it right on there. Then we're going to put on another washer and another nut. All right. Get the last one on there. And then we're going to check and see if it sits flat on a surface. Feels like maybe there's a little bit of wobble. You can adjust it by hand a little bit if we need to. There, that feels pretty good. And then we'll go ahead and just use some pliers and some needle nose pliers, and we can go along and just really tighten them on nice and firm so that they don't move or wobble. Now that that's there, we're going to put the screen on the top. What we want to do is just put nuts on there, just ever so slightly down, just enough that we can get this whole thing through there and put a washer and a nut on. So just put 4 nuts around. That's good. Now, I want to make sure that when I put the screen on, you can see there's a mark right here from before. There's also a mark on this screen. That's why we marked them. So when this goes on, it goes on like that, so the marks line up. So I'm going to kind of set it upright like this. This is how it will go. I'm going to carefully set it down, and we'll put washers on the 4 screws. Okay, put this little guy right on. Should go on in a way that lines up. And put washers on. Put a washer and a nut. Just finger tight. Oops, wrong size. We can adjust these nuts and washers down a little bit as needed. There. I'm going to adjust this one down a little. So what I'm going to do now is adjust it so that that screw is just perfectly flush with the top. So move this back, screw this in a little bit more, move it back. There, that's good. Once it's set, tighten them up. That way the height should be very, very close to being nice and level. There. A little bit more. There. A A little bit more. Okay, that's good. And now we'll just tighten those up using the needle nose pliers and the other pliers. Once I've got the nut secure on these 4 feet, you now have a neat little heater rack. The top is a flat space to put the medical instruments. You've got room for convection airflow and room underneath for air to move underneath and circulate around the heating element. And it will just sit on its 4 little feet like this. See that? The last step with this is we're going to take the thermocouple. If you remember in the parts we're looking at, there's a thermocouple reader, this little chip, and then the thermocouple sensor. We're going to install the thermocouple sensor right now. Let me take this little nut off. Again, it's another metric nut. It's the same size nut that we used to bolt the heating elements on. And I just want to put this element somewhere on the very top and near the edge, not right above the heating elements. If it's here, it's going to read a little too hot. We want it to be right near the edge, so I'm just going to pick here. I'm going to use a screwdriver like before. A very high-tech approach here, but that's all you need. And pull this out. So this is the part we want in there. It's the sensor. Kind of push it right up through there. And I can just put the nut directly on. You don't want to over tighten the nut on the sensor. It's not a very high strength part, but I give it a little turn with the pliers, just by hand though. Okay, so now we've got the lead from the thermocouple, and we've got a set of wires for the heating elements. I'm going to gather up the heating element wires, and I'm going to try to run them off to one side like this. They're off to one side, and then the sensor wire can run off the other side. And let's go over here. We're going to put this onto the pillow, and I can just center this right underneath here. You can see these all run off one side. In fact, I could tuck these right around that foot. See how those wires are tucked right around the little foot there, so they all come out together in one bunch. Likewise, this comes out here. This is the wire for the sensors. So I have it, the power wires are exiting on the left, and the thermocouple wire exits on the right. And when I put this right on top of there, it seals down, and there's very little air space left. It's really not any threat to the wires. They're not going to get cut, but these wires are going to run. In fact, what I can do is just temporarily put a little knot there, right there. And the next step is to make the control box that will sit right here and will control the thermostat system. All right, so the next part is we're going to put all of the holes necessary in this electronics enclosure to build the control system. I'm going to just take these things out of there. Keep track of them. It comes with a little seal. You don't really need to use that for this project, but you may. What you need to do is in the book, and this is for the download as well, there are a couple of pages that are just a drill template. One is for the cover. The cover will hold the liquid crystal screen, and then one is the drill template for all the other holes in the box. So what I did is I printed those out. I've got them right here. That's the cover, and the top there. And the first thing I'm going to do is just measure it to make sure that the scale is right. Sometimes when you print something, the scale is wrong. So 159 millimeters. I can lay that right on there. And yeah, it is. So that's fine. And once again, yeah, 159. So these are to scale. So I'll start with the cover, and I'm going to to make it easy, I'm going to just go ahead and cut these things out. It's a lot easier to deal with when they're cut out. If you have a box that's a totally different size, then you might want to improvise a little bit, or you might want to figure out, okay, how to position these holes in a way that will make sense for the project. But as this stands, I'm gonna do one for the lid, and then I'll show you. See, I can just put this right on. These are the 4 screw holes that will hold the liquid crystal display on. So I want this to be nice and even. And then I can take a punch, and this is just soft plastic, so you don't need to use a hammer. Just push down and move it around a little bit, and it will leave a mark in the plastic, like that. And this little mark will let me know where to drill the holes. So there. So for this lid, take this away. I can just, if I look in the reflection, I can see where the holes are. I can use the Sharpie, put a little mark, make it a little bit easier for me to see. Okay. So now you can see I've got the 4 holes marked. I'm going to set that aside, and I can do the same thing for this. I have this template cut out. I'm going to just put it over this box and fold it right down. Fold it so it's pretty nicely fit. I used a little bit of tape, and I taped it down, and I taped the edges together, so it's pretty well secure. The reason I did that is because there are so many different little holes in this that I don't want it to shift around, or it'll kind of mess things up. So I'm going to go along, and I'm just going to put a mark on each one of these holes. Push it in, give it a little push. It will make a dent that you can see and that the drill can push into without sliding around. Go right around the edges here. And it says in the book there's a good picture of exactly what goes where, and I'll show you too. The template lets you do this much faster than trying to measure this all by hand, though. So it's actually a really convenient way to work. You can just make all the marks in one go. Okay. There. There. Okay, 2 more and we'll have it marked. All right. Okay, so I went ahead and I put a little Sharpie mark where each of the holes will go. You can see it matches the template pretty well. So there's 3 holes on this side, a couple holes on that side. Look at the top, a couple of holes there. So that's good. Now we're going to go ahead and drill. Now you can see on the template it says the hole size to drill them. Looks like everything on this side, is 1/8 of an inch, so I'm going to just get an 1/8 of an inch bit. Okay. Any other 1/8 of an inch? Okay. Next, looks like, we'll flip this up. 17/64ths. So I'll get a new bit. All right. 17/64ths. Put that right there. All right, 1/2 inch, 1/2 inch. Anything else? Aha, also 1/2 inch. So word to the wise, if you're gonna drill 1/2 inch, you should probably drill a smaller size first as a pilot and then use the 1/2 inch. That's what I did over here, and then I used the 1/2 inch as the second bit. I was being lazy and decided I was going to just drill it out with this, but that's what happened. When you're drilling through acrylic, it's important to go very slowly. If you push too hard, you'll get some cracking in the back. The back will crack out. But if you go very slow, it will go through nice and cleanly. So acrylic is usually what's used for the clear covers of boxes. The box itself is ABS plastic. All right, so here is the box with all the holes drilled and the lid with all of the holes drilled. And I want to do one last thing before we start putting the components into the box. I want to put 4 little rubber feet on the bottom of this box, and what that does is hold it off the tray just a little bit so that we don't get any interference with the screws that stick through and the aluminum tray. So I'm just going to put 4 little feet underneath here. Makes it very nice. I don't want the feet to go where the holes are, so give it a little bit of room. But it'll be like that. And now you can see, if we go over here, we're going to just look at it. This will fit very nicely right here. We're going to start putting the components in. Most of these steps can be done just with needle nose pliers and a small screwdriver. Also, there are a lot of these little tiny screws, and you can see in the book I list which screws there are. Actually, I'm working from a pile of small screws that I collected for this project. The first thing we're going to do is put the MOSFET, or the transistor switch, in, and when you have this oriented like this, the transistor switch will go right here. Go right over those holes. What I want to do is put these screws in from the back, just like this. We'll do one and then the other. And there's a nut that goes on the inside. Just like that. And put the other one. I'm just going to put these in finger tight. We'll tighten it all down once the switch is put in. One other thing to note, you can see how this has a set of 3 pins. When you buy these, they usually are facing out the side, these 3 pins, and I bent them so they're standing straight up like that. So you might do that. You can just bend them by hand or use some needle nose pliers. Put this right on there. See, they fit right on. And then as a last step, we're going to just use 2 more of these tiny little nuts. And I am going to use the needle nose pliers just to put them on there. It's kind of difficult. There we go. Kind of put that on there. The other one. Put that on there. Ever so slightly. Okay. Now what I can do is hold it with my finger on the inside and turn the screw from the back. Likewise, hold the other one. Turn it from the screw. There, we have the MOSFET installed on the floor of the compartment. The last thing I want to do is, you see these screws? There are some electrical issues if these screws make contact with that base. So what I want to do is I want to cover those screws with a little bit of tape. This is the only time you have to do this, but I just wanted to show this to you right now. No better time than the present to do it. So there, the screws are protected. There are little feet that helps also, and that's installed. All right, this next step, we're going to install the microcontroller into the box, and in the same step, we're going to be installing the box right onto the tray. We're using the same screws that mount this little sled onto there. So it's sort of two steps in one. And what I want to do first is take this box, make sure you align it like this so that these two holes are facing out this way. You can get it as centered as you want, and you can see there are these holes like this, and we're going to drill right through these 4 holes with the 1/8 inch bit again, and this just holds this box right onto the tray in the same step. So I'm going to go ahead. All right, so I've got the 4 holes drilled straight through, and I have the little sled here. Something else I noticed, when I went to put this in, there was a little bump that was in the way right there, just like this. And if you want, you can get rid of the little bumps easy enough with a pair of pliers. You just put it in and the little bump will break right off. So don't worry about that. I'm going to get this lined up, the holes underneath. There. I can put this on, line that up too. And I'm going to push some screws. These are 1/2 inch length, or right around a little bit more than a centimeter. Push that right through, all the way through one, all the way through the tray. You can see it right there. So next, we're just going to put nuts on. We'll secure the whole deal to the tray. Next one, right through there. And we're just going to continue till they're all in. Okay, so looking into the control box, we've got the control box mounted down to the tray. We have the Arduino microcontroller, and right now it's just popped in there. We'll put some screws in to hold it in place later, and then we have the MOSFET module. The next step is putting in this automotive relay. There are 4 wires we're going to connect to it. We're going to connect 2 wires to the coil. You can see between 86 and 85 on this one, that little symbol is the coil. And then 2 wires between the normally closed contact. So when there is no power, when the coil is not energized, it's connected. And that would be between 30 and it says 87A. I think in the book the numbers might be the same. Yeah, they are the same, but they might be different. Just follow this little instructions. The thick wires go to the switch because we're switching a large power. The thin wires go to the coil. We're using a small power to switch a large power. Go over here. So I have this automotive coil, and we're going to put on the thick wires first. Why not? I have about 4 inches of 16 gauge speaker wire cut. You could use 16 gauge wire of any kind, really. Stranded seems to be the easiest to work with because it's flexible. I'm just going to peel it. I also think it's easiest to strip both ends of the wire right now versus waiting later. I have this peeler. It also has crimpers at the top, and we're going to use those in a second when we use that. So there, so I've stripped all 4 ends. Really only need about 1/4 of an inch. And we just give it a little bit of a twist to clean it up. It's stranded. We don't want those little strands sticking around. Do the connectors one at a time. Goes right on there. You can see it goes right on, and then we'll use one of these. You can see the color, the blue color is there to let you know which kind to use. I'll just squeeze it, flip it over, and squeeze it again. And that produces a nice, strong, crimped on connector. There. So now I have a pair of connectors, and we'll look at this relay. I want to use this between 30 and 87A. So I'll flip that over. We got here. Looks like 30 is right here. Just push that right on. And 87A, this one right here. There. All right. All right, so I have the thick wires connected. Now we're going to pick a couple of thin wires. I can just use a pair of wires from this bundle of pre-made wires with connectors. I'd like to keep these connectors at this end. We can use those. And then this end, I could either cut them off, try to get this in focus. I could either cut these off, or I could use a small screwdriver or a pin to remove the shell. Use this utility knife. I can kind of just pick the little tab off. You'll see what I'm doing in a second. Pick the little tab off, and you can remove the little crimp-on housings. That leaves these thicker metal connectors, which actually will work well for crimping on the thicker connectors. It makes life a little bit easier. You can fit those right in. And when you crimp it, it's got some thickness to hold on to. Like that. See, and that's actually quite secure. If you peel these tiny wires and you try to crimp larger connectors like this on, you might have a harder time. You might have to double up the wires, or you might have to solder the small wires on. So now I have a small set like this, and we're going to connect this to the coil. Now look at this. Coil is 86, 85. So 85 and 86. So that's these side pins. There. And that is the component we're after. I put one small 1/2 inch 1024 screw through, put the relay on. You can use a washer. and a nut. And there you have it. It can just sit there. It all just kind of fits together. We'll have room for the wires when it's time to deal with those. Alright, the next step is to install the on-off switch that will be used to control power for the heating coils. The switch is going to go right here in this hole, and the first thing I want to do is put on 4 inches or so of 16 gauge wire again, just like we did with the relay. And notice this switch has lugs that I could screw down to hold the wires on. You might want to use crimp connectors to make loops. Some of the switches will have just push-on blades, just like the relay did. Either way, it's a little bit close quarters for all the components in this box, so I'm going to fold this wire up like so, and I'm going to wrap some electrical tape over the contacts and around, just to make sure that there is no chance of unwanted contacts being made. There. Now I'm going to take off the rings and just put that into the box. We'll get it all installed. Okay. There. And there should be just enough room to put wires into the terminals on the MOSFET as well. That's good. Alright, now we're going to install this small push button into the side of the box. It'll actually go right here. And this will be the button to start the cycle or to restart the cycle. Notice we have a wire we need to attach to this little push button. So I'm going to come over here. I'm using a soldering iron, and I'm going to just install a pair of wires that I take from this bundle again. You might be able to find online a push button that already has wires attached to it, but it's easy enough. You don't have to use a fancy soldering station like this. You can just use a small soldering iron. I'm going to just clip off the ends. A lot of these tiny wires are thin enough you can just peel them by hand. And just come down here and check and see if this is hot enough yet. I can, yep. I'm going to just tin the ends of the wires, give them a little bit of solder. See how we did. Yeah, now they're just tinned, they're silvered a little bit. If you're a stickler for detail, you could go ahead and trim these down even a little bit more now. So they're just like that. I have the button. Something I like to do is use a little bit of sandpaper if this has been in a drawer, and I can just sand the contact a little bit. Likewise. There. Now the solder should stick quite nicely to that. There. Okay, I have the wires complete and a little bit of tape on to help hold it together and keep it from shorting out against anything. I'll take the nut off of there and we're going to just install it through the hole. So we have all of the hardware installed. The next series of steps will be about connecting the components and wires to the Arduino board. Before we go any further, I'd like to mount the Arduino, and then I would like to carve this hole out so that it is a straight shot for plugging in the USB line. Alright, so I carved out a square hole that should accommodate the USB wire. I'm going to pop this back in. I pulled it out so that I could keep the shavings clean. Popped right in. Now we can try this out. Got this USB line. Just go right in. Plugs right in. Provides access. And pull this out. If you're operating this in an area where there's a lot of dust or dirt, you can put a piece of tape over that temporarily. Otherwise, I wouldn't worry about it too much. Now, let's bolt down the Arduino. There are only 3 screws you can really use. There's a hole right there. There's another one over here. And there's one there. There's a 4th hole, but there isn't enough clearance around it for the head of most bolts to work, so don't worry about it. All right. Now the fun can begin. We can start putting the components in and attaching them to the Arduino controller. The first thing we're going to put into the controller is this little piezo speaker. Sometimes they come with connectors attached, sometimes they don't. I soldered this pair of wires onto the back. There had been an old connector and I just put these on just like we did with the push button. Now I'm going to put this, come over here to the book. The speaker connects to the Arduino between pins 3 and 4. And when we look at the controller, 3 and 4 are down here because the USB is facing that way. So it'll be 3 and 4. So here we go. It doesn't matter which way they go. It's actually not polarized. Okay, we're going to install the thermocouple reader module. This is the Max 6675. Pretty inexpensive thermocouple reader, and it uses digital in-out pins on your Arduino, and it plugs into a series of 5 pins in a row. I had to straighten out these pins a little bit so that they're aiming more or less up. When you first buy one of these, a lot of times the pins point in one direction, or it may not have any pins at all. But before we can plug it into the Arduino controller, we need to connect up the lines from the thermocouple. Remember, in an earlier step, in case you haven't done this, the thermocouple probe is installed through the top mesh. The wire is meant to run down and out of the oven section, and it just ends in a pair of connectors. And what we can do, the board is marked plus and minus, and by convention red means plus and blue means minus, so we can just install these wires. I'm going to loosen these terminals up. Here's the thing I always forget to do. Make sure you put the wires, make sure you feed the wires in to this hole in the box first, and then we'll put them onto the board. There. Should let us bring the probe right in. Okay, red means plus, blue means minus. Okay. It's important to make sure these connections are actually pretty tight. If they're loose, you will get an intermittent signal read, and that's no fun. Things will be working and then they'll just stop working. Okay, let's get this sort of lined up. This is going to plug into a row of general input-output pins, numbers 8 through 12. If you look here, 8, 9, 10, 11, 12. And the way this is oriented, they're right down here. So these pins are just going to go right into that row. Okay, I just pushed it right in. You can see there is room. It's not really touching the chip. There are no contacts being made between wires and the chip, and it just sits right there. There. I actually used a piece of that silver furnace tape just because I know this stuff is very strong and it's very sticky, and it will provide some relief. So if this gets tugged on, it won't pull the wires out of the circuit board. Okay, let's prepare the liquid crystal screen. This is a 16 by 2 or 1602 liquid crystal display. It means it has 16 characters across and 2 lines high. And it has what's called an I2C board. You can tell if it has I2C because it has a little circuit board that's separate on the back, and it has 4 wires out the back. If it doesn't, you'll have a lot more wires to deal with. The I2C protocol lets you run things like a screen or like other devices with only a few wires, and you can see the wires are ground, VCC, looks like SDA, and SCL. You don't really have to know what those mean. We'll show you how to hook them up. I'm also going to use 4 of these wires. They're a longer size than they have the female connectors at one side and the male connectors at the other, and it will just let us patch this into the circuit board. First thing though is we're going to mount it onto this lid that we prepared before. Now the screen is positioned like this, so the I2C, when it's all assembled, the I2C will be pointing to the left inside. So if I flip this thing over, it should be pointing to the right, and it's at the top. And I'm going to use some of these 1024 by 3/4 inch long screws and some nuts. Again, just finger tight at first. We don't want to bend or break the circuit board. We just want it to be secure enough that it doesn't rattle around at all. Okay. So, looking at the orientation, the I2C wires are pointing off this way. So when I flip it over, there's the display screen. It's got its I2C on the left this way. Okay, well, I like that. Why don't we go ahead and put 4 more nuts on to just lock against the others. If you wanted, you could use a lock nut, a little nylon lock nut, but it's sometimes just as easy to do this. You stack a couple of nuts, and you can give the top one a little twist, and they'll be secured together. Okay, I just put the ends of these wires onto the 4 connectors. I took the wires apart into little pairs. It helps me keep track of what they mean. I have a red and black, and I used black for ground and white for the VCC. When I look at the schematic, this is what we're going to do. The VCC is going to go to the 5 volt. The ground is going to go to ground. SDA is going to go to A4. And SCL to A5. So let's do it. I'll just bring this right up here. And when this is all installed, it's going to fit on like this. So maybe it makes sense for me to roll it open to the side like that. I have lots of slack because I use the longer wires. That's good. And there are the row of connectors up here at the top. And I can see 5 volts up here, right there, and ground right next to it. So there, if you can see it, 5 volts and ground. And then we're going to hook SCA oops, right now SDA to A4. Come right up here. Take your time. SDA is brown. Over here, we're going to connect brown to A4. And when I look at this, I can see, aha, A4 and A5 are right here. They're the last two on the end. So A4 and then A5 is the last one on the very end. All right, make sure that's in. Here we have it. So that is the display connected up to the Arduino. Now we're going to connect the MOSFET module up to the Arduino, and we're going to be using 3 wires. I'm just going to grab 3 of these. I can just choose 3. Notice they have the pins on them. And we're going to connect 3 pins from A1, A2, and A3 to the signal, VCC, and ground on the MOSFET module. So let's just go one wire at a time. In fact, I'll pull these right apart. All right, signal wire will go to A3. So when I look at this, you can see right there it says signal. I'll just plug that right in. And we'll go to A3, which is right next to A4. Okay, it's plugged into A3. Next one, and just go really slowly, make sure they're all hooked up right. VCC goes to A2. The colors don't really matter, it's just there to help you. So, help you to keep things straight. Okay. So, let's connect VCC up to A2. Again, they're just all right in a row. Tried to set things up. I tried to set things up so it would be easy to do. And the last one, ground to A1. So we'll just come over here, connect up ground, bring it around and plug it into A1. There. We are really coming down to it, so now it's time to put the 12-volt connector in. These are kind of neat. I have a 16 gauge connector and it has the thicker 16 gauge size wires, and I want to run these wires right in to the hole next to the switch. That's how they'll get into the box. Okay. So that's essentially how the power gets into the box, and then the power comes out of the box to the heaters through this hole. And I prepared a wire for that. It's about 1 foot of maybe 40 centimeters of this 16 gauge double wire again. And just for convenience, I marked with some tape positive and minus. Those will be inside the box, just so I can keep track of what I'm doing. Push those through from the inside. So what we have at the end of this step is a collection of all of these wires sticking up from the various things, and we're going to start putting things together in the next steps with some wire nuts and get it all wired together. Okay, now rather than fishing through this up close in sort of a rat's nest of wires, I did all of the wiring for these steps, And what I'd like to do is just show you the schematic of what I did. And just flip this over to the full schematic. This should give you some idea of how the power from the power jack is connected, both to the switch and to the MOSFET, the automotive relay. And once I got this all kind of connected together, I used some little wire strapping to tidy it up and kind of tuck everything in. There we go. And there's the screen and switch. And I'm going to put the screws right in. There. What we're left with are a pair of power wires coming out, and here's the heater system and this whole bundle of wires going in. This set of wires coming out is this pair of wires right here. So they need to come out and then get wired to those heating elements. Before we do the, and we'll use 3 wire nuts, basically, to just hook them right together. What I want to do first is just cut these wires to length, because right now it's a full meter of red wire. We don't need that much, we only need about, well, you can just do this by eye, but I think we'll leave enough wire that it can run out of the pot and end somewhere near this. I'm going to put this insulated pot right on the top so you can see that's how it should be. The wires should just be running right out the edge, and they should be laying flat. In fact, if you wanted to, it's a good idea now to just check and make sure that the wires are coming out in a way that they can all just run out and be nice and flat. You don't want them bunched up. You also don't want them tangled around in there. They should just come down, kind of go out the side. That's great. I'll put this back on top so you can see that. Okay, so with that on the top, I'm going to just stretch a length around that I think will work well. Not too much, but you don't want to cut off too much either. I'd say about that long. There we go. There. Okay, so I have all of the wire pairs stripped, and I can start grouping them to do the wiring. Looks like I have 2 heater coils that are in series. So let's just pick 2. I'll say these 2 we're going to wire so that they're in series. They're wires. All that means is we're going to just twist 1 wire from each coil together. So I'll just do that right now. And if you notice, that's all that's there. So we'll put 1 little wire nut right on there. There we go. That is done. The other pair of coils are wired in parallel. So they're just there. It's as if you take the 2 wires and you put them in parallel. So I'll take these here, and I will just put 1 of each onto the other. Okay. That's that pair. And then what did I do? I put that first pair that's in series, I put those in parallel with those as well. So, easy. Got these two. We have the 3 wires from the first set. If we don't do anything with the middle one, I'll take one of these. I will put it to one of these. And I'll take the other one. I'll put it to that one. Okay. So these should be these 2 wires right there. The last step is to connect the power coming out of this box to the connectors for the coils. It doesn't matter which way it's wired, they're not polarized, just one to the other. So I will twist it on there. We've left enough wire that these wire nuts will all be safely outside of the heating chamber. The only thing in the heating chamber are the heating elements and then these high temperature wires coming out, so it's good. All right, now let's flip this thing over and get the wires just kind of tidied up a little bit. So it will sit like this, and we want to just run all these wires underneath the legs. I kind of run them under the legs so they stay safely out of the way, and so they run flat. That's the main thing, is that they're just flat enough for the edge to rest right over. Okay, looks pretty good. What I'm going to do now as an additional step is tidy this up with some zip ties. I have a couple zip ties. Put one around here. I'll put one right up here too. Still outside of the heated pot. We don't want melted zip ties in there with your medical instruments. Okay. All right. And let's just put this oven on, see how it fits together. All right. That is pretty darn good. I think I might just tuck this and run this out a little bit. And we can kind of fold this right down in here. Keep these out of the way. And if I wanted to, I could use a final zip tie right here against this whole bundle to keep everything in one neat little group. There. So now you've got a 12-volt power input, which goes into the microcontrol system. You can switch on power to the coil or switch it off. We have a little input down here that would let you connect to the USB port to download your data, which will automatically record. You have the power wires that come out. It's been wired out here externally for 12 volts. They run under here and they go flat right under this edge and then inside the chamber. You have the heating coils on their own level so that air diffusion will let the heat rise and fill this chamber with the requisite temperature for sterilizing medical instruments, killing bacteria and spores. And then we have the thermocouple probe, which runs down, out, and into the control box where temperature is monitored. Now we have completed the hardware for an open autoclave. The next step is to put the software into this system so that it will operate as a thermostat and as a timer and as an alert to let you know when the system is done, and also as a data recorder to let you verify that the process was done properly. Why don't we move this to the computer area and we'll do the next steps. Alright, now we're going to look at how to install the Arduino software inside of the Arduino Uno inside of the Open Autoclave. The things that you're going to need are your finished and wired Open Autoclave and also a computer. It could be a Mac, it could be a PC. Either of them work fine with Arduino. And you'll need a printer cable. I want to show you what happens. Right now this is all wired, it's all put together, but we don't have any software in it. And I'm just going to plug it in, and there. If all goes well, the screen should light up. You'll see a little LED on in there, but really nothing will happen. Also, see this switch needs to be down. If it's up, it kind of shorts out the power because this is being powered by the USB and not by the 12 volts. So you can, I'll turn that back off, and it should come back. Nothing much happens. I'm going to just leave that plugged in, and we're going to go to the computer for the next steps. Alright, so the three things that we're going to do on the computer are, number one, we're going to install the Arduino program on this computer so that we can connect to the Arduino in the Open Autoclave. Number two, we're going to download stuff from GitHub. GitHub is an online repository of files. It's a great place for a developer like me to put software that would let you download it and install it and use it. And then number three, we're going to put that software onto the Arduino in the Open Autoclave. So I'll just put this here to keep us on task. Step one, install the Arduino program. I'm going to launch Google Chrome. You can use whatever web browser you want, and we're going to go to the Arduino homepage, arduino.cc, and if I open that up a little bit, you can see the bars across here. We're going to go to their tab marked software, and then there's a section called downloads, and it pops up. And if we scroll down a little bit, about halfway down the page, it says download the Arduino IDE, and then we have all of these options on the right. Choose whatever operating system you're using. I'm using Mac OS 10. Click on that. It would be great to contribute to them if you feel like it. They make all kinds of great products for free. I've already contributed, but I'm just going to download right now. It takes a few moments to download. It's not a huge file. We'll just let that come down. Okay, I have my downloads folder right here so you can see what just landed on the hard drive. I'm going to minimize that. It's a zip file. If you're using a Windows machine, you might right-click on that and say Unarchive. On a Mac, you can just double-click and it should open that right up. Extracting it. Okay. There it is. This is the Arduino application, and I could put that into my applications folder. And once it's there, I should be able to just start it by using Spotlight. For instance, I'll just say Arduino. And it's starting up over here. This will take just a couple of moments. which I will edit out. Okay, there. Once the Arduino IDE starts, it will give you a little empty window. This is where you would write your program to make the Arduino do stuff. You can see here's the program. There are a couple of drop-down menus. And that's it. We've done that step. So the Arduino program is now up and running. I'm going to go ahead and just hide Arduino. We'll come back to that. Step number 2. We're going to download stuff from GitHub. So we're going to download all the files that we need to make the open autoclave run. I'm going to go back to Chrome, make a new tab if I want to. I'm going to go to github.com, github.com. And the easiest way to find my files, really just go up here to their search window and just type open autoclave. Two words, hit enter. And there it is. It comes up. It's under my blog's repository name, Idea Propulsion Systems Open Autoclave. I'm going to click on that. Okay, it opens this window and it includes a whole set of files. You can see here is a folder, Arduino, software, autoclave log sheets, notes, photos, and the book for how to do the project. The easiest thing to do is to just come over here where it says clone or download. I'm going to click on that and then just click on download zip. It will download this whole thing as one big file. Okay, so it's downloaded. I'm going to minimize Chrome. And if you look, now we have another zipped file in the downloads directory right next to the Arduino zip. I'm going to double click on that, give it a second, and up it comes. These other files, those are now old files. I'm going to delete those just so we have this. If you want, put this into a directory somewhere where you won't lose it. I'm just going to open it in downloads right now to show you. Inside of it, there is the Arduino software. This is Open Autoclave. If you open it up, you'll see there is the icon. It's a file that ends in .ini. That is the file we're after. If you just double click on that, it opens it up inside of the Arduino program. Notice I double clicked and it opened up this window. Close that. This is the program we're after. So this is the software that will make the Open Autoclave do its thing. You can see it says Open Autoclave software version 18.10.31. You might have downloaded a version that's a little bit newer. It has some configuration variables. You can scroll down, you can see the entire code. And if you're into programming, feel free to make modifications and adjust it how you want, but this should work just fine, exactly as is. So we've done step 2 now. The last step is to put this software into the autoclave. Now, the last step is to put this software into the autoclave. The last step is number 3, to put the software into the Open Autoclave. You want to make sure the Open Autoclave is plugged into your computer using the printer jack. We did that before this started. You can see that with the printer jack plugged in, it lights up, but not much happens. We want to upload this we want to upload this to the Arduino. Come up here to Tools, and you want to come down here to where it says Board. Make sure Board is set to Arduino Genuino Uno. These are all different boards that you could be using, and for whatever reason, it's called the Genuino. Again, under Tools, now we want to set the port. Come down to where it says Port, and choose the USB port that has the Arduino on it. You can see sometimes you have a couple options, so choose the USB port. And then you should, if all is set properly, you should be able to just come over here and click on this button that says Upload. It says it's uploading. Oh, success! The software is loaded. You can see we're getting a temperature reading from the probe. There's a little blinking message that says heating. That means if it was actually connected to 12 volt power, right now it would be warming up. And that's the default exposure time, 120 minutes, 0 seconds. When this temperature goes up to 160 Celsius, this timer will start counting down and the autoclave will do its thing. Looks like we have a complete and ready to test out open autoclave. I want to show you how to download the data that you recorded from the open autoclave into your desktop computer. This is something you might want to do if you're using this as part of a medical operation and you want to be keeping records of every time it's been used. The open autoclave records every session, every heating session that you do. And the way you connect it to a computer is with this USB line. So it's just a standard printer line. And if you remember putting this together, there is a hole right here that should line up pretty closely with the USB ports. You can see I'm going to plug that right in, push it, and it will start. It says heating. It's really not, because we're not connected to any 12 volt power. Also, for this step, it's important that this switch is flipped down. If it's flipped up, it kills the power that's coming in through the USB line. So I'm going to push it back down. And now we're set to download. So let's go over here to the computer. The first thing I want to do is start the Arduino IDE program. I'm going to use Spotlight here. If you're using Windows, you might just start it some other way. It'll take a moment or so to load, and then it loads up with a blank sketch window. To load up the serial monitor, which is what you'll use to view information from the open autoclave, you go up to Tools. The first thing you want to do is just check to see that the port is set to the Arduino. You can see there are a couple options. One says Bluetooth, one it says Arduino on the USB. That's the one we want. And then if you just go to Tools, Serial Monitor, it opens this window. Give it a moment, and the Arduino sends over a little line of text, and it's a menu. It says enter D for download the EEPROM, asterisk for erase the EEPROM, T is for a current temperature read, and I is for info. So you have those options. If I typed I, for instance, and pressed return, the Arduino returns a little block of text here. It just says something about the build. This lets you know what version of program is in the Arduino right now. If I typed in T for temperature and press enter, it returns the current temperature reading inside the Arduino along with a timestamp. This might be handy if you wanted to use a laptop as the data logger instead of the internal logger. A laptop with a small script could just be sending that T command every minute or every second if you wanted to, and it would just return the temperature each time. What we're interested in doing, though, is getting all the information out of the Arduino that has been logging. So I'm just going to press D for download, hit enter, let it go. See, it's still filling it up. It just read the entire EEPROM into the serial monitor. So what I can do now is scroll up. It's all 0, 0, 0. I'm going to scroll up to the start of these numbers. It will always start with the number 13, and you'll see why in a minute. 13 is kind of like a punctuation mark between each session. I'm going to hold down the Shift key and click here. Actually, looks like there are a few more. Oh, that's good. I selected my data. I'm going to copy it, Command C, and then I'm going to come down and start up. I have Open Office. You could use Excel, anything that will give you a spreadsheet. This would be very, very useful. Here's a little spreadsheet. Make this a little bit bigger. And I'm just going to paste the values into there. So now you can see I pasted it all into column A. Looks like it's all in there, and it goes down, 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 down. Looks like I have 213 lines. If you want to just see what this looks like, I could click on the top of column A and come right up here to Insert Chart, for instance. Give it a second. Oh, there. I like that. There's a column chart. Just say Finish. You can play around with the labels and whatnot, but you can see this is temperature in degrees Celsius, and this is minutes. So every single minute that this autoclave was active, a new temperature reading was logged, and you can see it started just a little bit below room temperature. The temperature climbed over approximately 70 minutes until it reached a set point of 160 degrees, and you can see the temperature went right along at 160 for 120 minutes, at which point the recording ended when the cycle completed. So I can just go ahead and save that. You might want to start a folder somewhere and let you save it with the name and the date. And that's it. That's how you get the information out of it. The last thing I want to show you, I'll just say discard. The last thing I want to show you is how to clear the information. And it happens pretty fast. All you need to do is type the asterisk like this, Shift, and if I hit Enter, that will clear the EEPROM. I'm not going to do it right now because I want to keep the data, but that's it. I hope that was informative, and I hope you can get that to work and include it into your pipeline, your chain of work. Thank you.